Hi viewer, this is EasyElimu channel. I'm Vincent Kanmwaya and I'll be your teacher for today. I'm going to take you through Form 3 mathematics work and we shall be handling Trigonometry 2. In Book 2 or Form 2 work, we learned about how we could find trigonometrical ratios of angles of 0 degrees to 90 degrees, which were acute angles. In this section, we are going to learn how we can find angles greater than 90 degrees and also more than 360 degrees using a unit circle and other ways like using calculator and mathematical tables. So we shall first deal with angles, finding coordinates of given angles in a unit circle. Then we shall use a mathematical table, and then we shall see how we can use calculators to find those angles. So we shall start with the unit circle. A unit circle is a circle drawn with the radius being 1 unit in each case. That means the diameter is 2 units, but the radius is 1 unit. In case that having a circle at that point, you will find that if you move from O, let's say the origin B point O, then to that one, that is our radius R. And if you see that radius, you will find that this radius, if you measure it, is giving us the radius is equal to 1 unit. Then we are going to divide this unit circle into 4 quadrants or 4 portions, 4 equal portions, in that you will find if we divide it into 4 equal portions, we are going to have 4 equal parts as part A, B, C, and D. Those are 4 equal portions in a unit circle after dividing in that way, with each having, for example, if this one was drawn to a Cartesian plane, whereby this one could be Y, this one is X axis, we should have that O from point O, here OX is our radius. OX from O to X is our radius, O to Y is our radius, but you may even include this one as E and then this one as F. So O to E, O to F, they are all equal. And they are all 1 unit each, and this is our radius. So we can notice also, after dividing a unit circle into these 4 portions, the first portion with the letter A, the portion with the letter A is what I'm referring to as, is known as first quadrant. That of B is the second quadrant. And the C1 is the third quadrant, and B is the fourth quadrant. This being a unit circle, we shall find that if you measure the angle around this point, for example, if you start at this point and then you rotate up to the same point, you will find that the angles at that point will measure up to 360 degrees. So meaning the angles in a circle, meaning all of them will sum up to 360 degrees. And if we cut it into 4 equal parts portions, as we have identified first quadrant, second, third, and fourth, we shall find that if we need to know what each quadrant will measure, we shall find it is divided by 4, and we will find each quadrant will be measuring 90 degrees. But remember, if you draw this one to a graph, if we have drawn it to a graph, we have said it's a unit circle measuring 1 centimeter or 1 unit each. So you will find that at this point, if this is a Cartesian plane and this is x-axis and this one is y-axis, you will find out that This one, this here, where the circle touches that point or the radius to with respect to x-axis, you will find here it will be positive 1. As you move on, it will be 2, 3, but this one, the circle will be positive 1. And here also at the y-axis will be positive 1. And the other way on the x-axis, this part will be negative 1. And the other one on the y-axis downward will be negative 1. That's how we can identify them. And we have said this is the first quadrant, this is the second, this is the third, this is the fourth quadrant. Then from that description, we can see that if you want to measure any angle in this unit circle, angles are measured in different ways. You will find that some angles are measured clockwise from the line OX, and others are measured anti-clockwise from line OX. OX is the radius of that circle, but it's along the x-axis, so that is the reference point, and most of the angles are measured with reference to that OX line. So if you measure that angle in anti-clockwise direction, moving to the west side, then if you measure that one in anti-clockwise direction, as I have shown you this way, the angle will be regarded as positive. In that, in case we have here, let's say this is angle theta, then we shall have that angle referred to as theta. So meaning that if you measure any kind of an angle in a unit circle in anti-clockwise direction, then that angle becomes positive. You are measuring it in a positive way. Then if you measure it in clockwise direction, that means if it is clockwise, you are measuring that angle with reference to this x, for example, then you measure it in clockwise direction. Clockwise, the way clock moves, so you are measuring in that direction. For example, you measure with reference to x and you find from this direction, from there up to this point, and you find that angle, for example, is alpha. So if it is alpha, then we can say the angle you have measured, you measured in negative direction. So the angle will be regarded as negative alpha, meaning that you measured it clockwise way. So what do we see is that if you measure any kind of an angle in anti-clockwise direction, then that angle will be regarded as positive. And if you measure it in clockwise direction, then the angle will be regarded as negative. So we can see that in case you measure any kind of an angle here, you will find that all angles that are less than 90, for example, if you have an angle which is from 0 degrees to 90 degrees, you will find that all of these angles lie within the first quadrant. In case I have, for example, in case I have an angle like 80 degrees, 70, 35, I have 40, let's say even 30 degrees, you will find all of this angle may lie, like here you may have angle 30, may lie at that point. You may have angle 80 degrees lying at this point, so you will find all of this angle is 80 degrees. They are all lying in the first quadrant. So angles in the first quadrant add up to 90 degrees. They all lie in the first quadrant because they are less than 90 or equal to that 90. But if you find your angle is greater than 90 degrees, if the angle is greater than 90 degrees, for instance, you have an angle 90 degrees, or our angle x is greater than 90 but less than 180 degrees, here we do say that that angle will lie in the second quadrant. Here, up to this point is where you will find 90 degrees. If you move, you measure in anti-clockwise direction, up to this you will be finding positive 90 degrees. And if you move from this direction as you move up to this point, here will be at 180 degrees at this point. So, as you continue to move, you will find here is 270 degrees and back to 0, of which we also find if you move in the other direction, as you move up to that point, it will be 360 degrees and you will have completed a circle. So, we can recognize that if you move from 90 degrees up to 180 degrees from this point up to this, any angle that lies between 90 degrees and 180 degrees, you will find that this angle lies in the second quadrant. Such angles may include 120 degrees. If you draw 120 degrees, you are going to find that the 120 degrees will lie at this point, for example. 120 degrees may be up to this point. So this one we may take it as, up to that point, we may take that one as 120 degrees. Let me remove this one for easier clarification. So you will find this angle here may be 120 degrees. So at that point, we have seen that any angle that is greater than 90 degrees but less than 180 degrees will be lying in the second quadrant. And if you have any kind of an angle which is greater than 180 degrees but is lying within 270 degrees, it is between 180 degrees and 270 degrees, then you identify that angle will fall or lie in the third quadrant. So we shall say this one will be in third quadrant. And such angles may include, if you have some of them, if you measure, you will find you will have angles like 190 degrees. You may have 220 degrees. You may have angle like 260 degrees, and so on. So many of them. You will find all of them will lie from that point to that. So you will find all of them will lie in this third quadrant. And remember, if you measure them in anti-clockwise direction, you will find all of them will be positive. But if you measure in clockwise direction, they will give you a negative and it will be not in that same position. So, as we have seen, that one is how is it. And then if you find an angle lying between 270 degrees less than x, but is through the limit of 360 degrees and 270 degrees, you will find that that angle will fall under this fourth quadrant. So the angle will be within the fourth quadrant. Such angles may include several, like 330 degrees, 345, 350 degrees, and so on. You may have so many of them. So you will find all of them will lie within the fourth quadrant. So let's see how we may assign coordinates to given angles after having identified in which direction you should move in positive way and which one is regarded positive, and also how we may measure a positive side angle. We may be provided with an angle like 30 degrees. If you have an angle of like 30 degrees, you will find like that angle lies at that position. If you have drawn your unit circle on a graph well labeled, you will find that this angle will be at this point. And if you look at the angle very well, you can construct a perpendicular at this point and find out that let this point at which the radius of the angle now touches the circle, and you find at that point let us assign it letter P. And if we say assign it letter P, we will find out that that letter P at that point will have coordinate x and y. And in order to find that coordinate, you can see that here we are having this. If we construct that perpendicular bisector, you will find it is giving us a right angle triangle. If this one is a radius of a unit circle, meaning the hypotenuse of that, if this one is the radius of a unit circle, then it means that radius will be resembling our hypotenuse of a triangle, which is 1. And from that, we can say we shall have, this is 1, this is 30 degrees. So we are going to have, this is the height, which may be A, and this is the base, which is B. So this is OX actually. So this is point P. So PX, to find PX is just simple, you understand, and even to find OX is simple. But OX represents the coordinate X. If you move from this point to this, that is what we are referring to as the coordinate of X. And if you move from that point to P there, then at that, let's call this point D. This is not OX actually, this is like D. So if OD will represent the value of X, then DP will represent the value of Y coordinate. That means that if the angle is extended on OX with DP, then the coordinates of X and Y for P will be equivalent to distance moved with that angle at the point where it touches the circle at that point. So we shall find that if you want to find, it will be that if you take the coordinates directly from a graph, you will find out that from the graph, you are going to have, you will find out that if you look at your graph of a unit circle, the point where P equals to xy and the angle is 30 degrees, you will find this point here will be giving you the x-axis at 0.86 and the y-axis will be 0.5 at this point here. If you have a graph well labeled in those boxes, you will identify so. But still we can calculate out and find what is x and what is y. Using this graph here, we can find this x and this y by saying like sine 30 degrees is the same as taking the opposite of hypotenuse, which y over 1, and you will find it is sine of y will be equal to 30, that is 0.5, and in x you shall say cos of 30 is equal to cos of 30. Cos of this angle is the same as adjacent of the angle, which is x, over the hypotenuse, and because it is a unit circle, that hypotenuse resembles the radius of the circle. So if we multiply by 1, you will get that x equals to cos of that one, and is going to give you 0.8660. So that is what we are finding. So if you resemble that one with what you get from a Cartesian plane, you will identify that the angle given here extends with a coordinate which can be calculated as we have seen. So the coordinates at the point, you will find it as 0.86 and 0.5, where 0.86 is the sine, the x-axis, and 0.5 is the y-axis. And from calculation, we have found in order to calculate y coordinate is equivalent to what? To the sine of that angle. So the x coordinate is also equivalent to the cos of that angle. So we can conclude by saying that we can also find the tangent of that angle, and we know the tangent of that angle is the same as, if you need that tangent of the angle which is tan 30, you will have to find the tangent is opposite of adjacent, so it will be y over x. And if you take y over x, it's going to give us y is 0.5 over x, which is 0.8660. So you will find out that it will give you something like 0.577. Let's just take to that to 3 decimal places. If we take to 3 decimal places, we are going to get that one. To 4 decimal places will give us that one. So having that one, we can even calculate the tan of 30 and find out tan of 30 to 4 decimal places actually is the same, 0.5774. So we can conclude that why we said y is equivalent to sine of 30. So tan 30 can also be written as y, but y here will be equivalent to sine of 30 divided by x, and x is the cos of 30. So x is cos 30. So meaning that tan 30 is equal to sine 30 over cos 30. So from there we can identify that if we have this one as, let's say, in case we have this angle here, if we have that angle there as theta, then the x-coordinate, we saw that if it is 30, x-coordinate is cos 30. So meaning that cos that angle theta will be equivalent to, because it's a unit circle, it will be equivalent to x-coordinate. And if you want sine of y, not sine of y, actually sine of theta. If you need sine of theta, then it is equivalent to y coordinate. That is what we have seen from the previous. And if you want the tangent of that angle, which is tan theta, you will find out that tan theta is equivalent to opposite of the adjacent, which is now y coordinate over x coordinate. And this y coordinate over x coordinate is the same as just writing sine theta over cos theta. So we can give it in general that if you want to find the coordinates of a given point which is subtended by an angle theta in a unit circle, then it will be given by, if it is the x coordinate, it is cos that angle, and if it is y coordinate you are required to find, then it will be sine of that angle. And if you need the tangent of that angle, is the same as taking sine of that angle over the cosine of that angle, or the y coordinate over x coordinate, and you will have fun. We are going to see trigonometric ratios for angles greater than 90 degrees. And here we are dealing with the angles which are more of acute angles but maybe obtuse. So let's see if we have certain angles. For example, we have been told we find the trigonometric ratios for these angles like 30 degrees. We may have 150 degrees, another one like 210, and 330 degrees. So having this kind of angles, we may require to find them on a unit circle, or use a calculator, or use mathematical table. But for this time, we are going to see how we can find them using a unit circle. We have seen if we have an acute angle such as 30 degrees, we saw it lying at this point, and we had here all of the values we got for cos theta. Actually for p here was 0.86, and the coordinate of y was 0.5. And we saw that if you find the cos of that angle 30 degrees, we were finding it to be positive. Cos 30 degrees gave us positive answer, and that positive answer was equivalent to 0.866 and something. And then sine of that angle gave us a positive answer of 0.5, and tangent also gave us a positive answer, and it was 0.5774. I remember that one is what we found in our previous section. Here we are going to find angles which are greater than 90 degrees. For instance, we may have, not up to that point, let's say 150 degrees. And if we have angle like 150 degrees, we shall find that this angle will be at this, because it's less than 180 degrees but greater than 90 degrees, it will be in the second quadrant. So that angle may lie at a point like there. So on measuring from this perspective, in anti-clockwise direction, you will find the angle may turn up to 150 degrees at that section. So it shall only leave an angle of 30 degrees to fill 180 degrees. But for this point, now our point P migrates from that point, let's say, and we shall take it to that point P. So this point P at this Cartesian plane will have coordinate x, y, and as you can see, with regard to x-axis, you will find that it also forms a right angle triangle with the x-axis at that point if we extrapolate that line there from that point. So we shall find that if we move to find the angle, for example, we need the y-coordinate. The y-coordinate is this coordinate here, and the x-coordinate will be the distance from the center to this point, for example, let's say D. So from the center is O, and to the point D, so we shall be finding that our OD, which is the x-coordinate, to find it is like you are taking, because it's a unit circle, we shall have the radius of the circle being 1, so that is our hypotenuse, and from that perspective, you will find out that the sine of the angle, which is 150 degrees, the same as minus this side. But before we get that point, we may just get what? We get the coordinates. But if you get the coordinates using a Cartesian plane, the coordinates of a Cartesian plane, you will find out that on a Cartesian plane, you will have this point as negative 0.8, actually it will give you negative 0.86 on a graph of a Cartesian plane well drawn with this y-axis and x-axis. Then you draw a circle of a unit measurement, so you will find that way, and this one will be positive 0.5 because in the y-coordinate at this point. So we shall have something of the sort. So meaning that if you need the angle sine 150 degrees, you will find, if you use that identity of this triangle, you will find at that point, you will be extrapolating that one, and the angle of this, for instance, if we move that way, so you will be having something of that sort. It's like an obtuse, but an extrapolate on this side. This side is 1, this is 1. So what I'm talking about is this x and this y. So that is what we are finding. And remember, this is our angle on 50 degrees. So meaning this one is 30 degrees to fill it 180, because this is one here is our straight line. So having that one, you know, if you need to find the side x of that angle, then it means it's the same as, after finding it on a Cartesian plane, we can prove by saying this one now will be our negative. The side, we need the side y, so it will remain the same. So it is y over 1 over hypotenuse. So this is the same as saying our y is equal to sine 150. So the angles which are greater than 90 degrees but less than 180 degrees, their sine or sine of that angles, it will always give us a positive answer. But if we do it, or we find the cosine of that angle, you will find that if you find the cosine of the angle, for example, cos 150 degrees, you are going to get, it will give you now, because we need the cos of 150 degrees and we are extrapolated, this one here will be a negative of the whole measurement. So we shall take this one as negative to represent this direction where we want. So it will be negative x over 1. That's what we are finding according to this triangle. So we shall be finding negative x over 1. And if we find that way, we are going to get our angle will be cos 150 degrees is equal to, if you divide, you are just going to get negative x. So meaning that if we find out this one, we are going to find out that we shall have our x as negative of the angle, because we are going to divide by negative 1, both sides by negative 1. So we shall find negative 150 degrees. So meaning that if we need to find this x coordinate from this point to that one of extrapolation, then it shall be negative of the cosine of that angle. And if it's the tangent, for example, in the second quadrant, let's do it at this point. So tan theta, we said for tan theta, we do take y coordinate over x coordinate. But remember for this case, y coordinate is sine of 150 degrees and x coordinate we are having negative cos 150 degrees. So, meaning if we do that one, we are going to get our tangent will give us a negative answer of sine 150 degrees over cos 150 degrees. And if you work out that one, you are going to get, for this point here, y equals to sine 50, you are going to get that one. Y is going to give you 0.5. It's the same as working out sine 30 degrees. And for this one here, you will get negative will remain, and then this one will be 0.8660. And here now, if you take 0.5, negative 0.5 divided by 0.866, you are going to get here 0. Negative actually, you will have a negative answer of 0.5774 from that perspective. So that is what we are going to get. And with that, we can conclude that if you are finding, for example, finding the angle here, let's say our angle which we are looking for at this point is not that 150. Let me give that angle like, let it be angle theta. So if we are finding that angle theta, then it means to find that xy, which we don't have, so to find the coordinates of P, which is xy, then it means from our working out we have found, we shall find out that sine of that theta angle in this second quadrant, we shall find it at y over 1. But it will give us that y is equal to sine theta. If you find cos of that angle, you will find it as negative cos of that, negative x over 1. And if you find out the value of x, you are going to get, it will give you negative cosine of that angle. The tangent also of that angle was giving us y, actually gave us y over negative x. Actually, it should be y over x, but for this case, should be y over x, but for this case, where the angle is here, we have found it will be equal to sine theta, which is the value of y, and our x here, we found our x as negative cos theta. So, on conclusion here, we are seeing that it will be negative sine theta over cos theta. So, we can say that if you are finding an angle greater than 90 degrees, but less than 180 degrees, meaning an angle in the second quadrant, any of the angle in the second quadrant, you will find the sine of that angle being positive, as we have found, but the cosine of the angle is negative, and at the same time, the tangent of that angle in the second quadrant is negative. We are going to see how we can find trigonometric ratios of negative angles. For instance, having a negative angle like negative 60 degrees, we can find trigonometric ratio for that angle using a unit circle. For the case like, we may divide it as we had divided it into 4 parts, and we find that this is all x, and having that, with the reference that we can measure negative 60 degrees, that is a negative angle. But remember, we said If you measure a negative angle, you are measuring it with respect to a clockwise direction. So if we measure with respect to clockwise direction with a reference of OX, then we are measuring in this direction. So meaning if it is 60 degrees, we are going to have it at that point, for instance, and we shall find this one is 60 degrees. On a construction, you will find it will give you a good scale level, and then you will find it directly from that graph. But for this instance, for drawing, you will find that we shall have it at that point, and this is a negative. We are measuring it in another direction, and we have found that one will give us a negative angle, but we shall write 60 degrees. The negative sign was to show us in which direction should we move. For ours was to move clockwise, and we find that one. So if we find the coordinates of this point on a Cartesian plane, if you go on and find out the coordinates of this 60 degrees, you will find out that it's going to give you something of 0.5, because, actually 0.5, and it will give you another one of 0.8, negative, actually it's a negative 0.86. If this one is point P at where the angle touches the line. But remember, this one is 1 because it's a unit circle, and whatever extends from the center to the circle, circumference of the circle is the radius of that circle. So from this point, we have identified the points at that one on a Cartesian plane. The graphs will identify and give you the values of P as coordinates of X and Y being 0.5 and 0.86 as shown. So on calculation, we can still see that if we need to find, if we extend that way, we are going to have a right angle triangle. If we label that point D, we are going to have this angle at 60 degrees. This one is O, this is D, and this one is point P. And from that point, we can see that if this one is 1, we can find the x-axis, whereby x-axis is not x-axis by the distance x, this distance, and the y-coordinate is equivalent to that distance y. So y-coordinate, this y-coordinate is equivalent to this distance from that point to that point where it touches the circumference of that circle. So if we do that, we are going to have that if we need to find the value of x, then we are going to find the cosine of the angle, cos 60 degrees, which is equivalent to x, which is the adjacent of that angle, over the hypotenuse, which is 1, because our circle is a unit circle, and any line from the origin of the center of that circle to the circumference of the circle is the radius. So we shall find that way. And this one gives us that x is equal to cos 60 degrees, which is giving us 0.5. Remember, this is a positive answer. That is a positive answer. And if we work out the other direction, like if we find the sine of the angle that is sine 60, we shall find that if we find the sine of this angle 60 is the same as taking the opposite of that angle, which is y, over the hypotenuse, which is 1, and we shall find out that it is giving us y is equal to, and because this one is moving in the other direction, you can see it's not moving in the y direction, so it's moving in negative y. This is y, so it is moving in negative y, this positive y, this is x, and this is negative x. So we shall find that it is moving in negative y direction, so it shall be actually negative y. So if it is negative y, then what we have here will be negative y, because it is moving in negative y direction. So if we do that way, we are going to have y as negative sine of 60 degrees. Because we shall divide both sides by -1, and we shall find that one. So if we need the tangent of that angle, tan tan 60 degrees, we are going to have, we say tangent of an angle is y over x. So in this case, we shall have now this one, and we shall just say it is y over x, but our y is represented here by negative sine 60 degrees over cos 60 degrees. And you will find this one is a negative answer, which is negative 0.5774. But you can still do this one by, instead of putting y over x, which is regarding to this, you can take it directly from there, and it will be negative y here. Actually, it's negative y. And if it is negative y, you will find out that if you take negative y over x, it will give you a negative answer. And if you replace that one, you are going to get, here y was negative sign, so you will find out the answer of that one. If we have that one, we can say that from that triangle we are formed and the coordinates we have been given, they are quite similar. So we can say that from this one, if we have this coordinate, then it means the tangent of the angle 60 then would be just equivalent to negative 0.86 divided by 0.5, because that was y and x, and if you do that, you are still going to get negative, the answer we have there. So in general, if you have a negative angle and it lies in the fourth quadrant, let's just give a summary of all the angles. In case you have any given angle and that angle lies in the first quadrant, or it is an acute angle, let's say all angles that are acute angles, these are angles within 0 degrees to 90 degrees. All these angles, we say they lie in first quadrant. And if you find the sine of that angle and also cosine of that angle, and you find the tangent of that angle, we found out that all of these are giving us positive answer. So we find out that all of them are positive. If you find an angle which is obtuse, meaning that it is from 90 degrees, the angle extends, is within 90 degrees, is within that range. Actually here, I should put this way because some of them doesn't apply. So if it is this way, you will find out that if you find an angle within that one, you will find this angle lies in the second quadrant. And that angle, we have seen, if you find the sine of that angle, sine of the angle, let's say the angle is x, so the sine of the angle is positive. This is the first quadrant, this is the second, this is third, and then this one is the fourth. And if you find the cosine of that angle x, you will find that the cosine of that angle is negative. Actually will be negative because of the line x is negative. So we shall find is negative. And if this one is negative, that automatically gives us that the tangent of the angle will also be negative. Then, in case you have an angle which lies in the fourth quadrant, the third quadrant I mean, that is within the range of 180 degrees, let's say it's an angle theta, within that range to 270 degrees, you will find that this angle will lie in the third quadrant. And this angle, if you find the sine of that angle, or the sine of that angle will give you a negative, because the y will have changed to negative. It is in the y downward direction. And also, if you find the cos of that angle, because it is still on the negative part of x, it will give you a negative cosine. And since the two you have seen is a negative, and tangent of the angle depends on the sine and theta and the cos of that angle, you will find that the tangent will be positive in that third quadrant. And if you have an angle ranging within an interval of 270 degrees to 360 degrees, you will find this angle will lie in the fourth quadrant. And if you find the sine of that angle, since it is in the negative y direction, the sine will be negative, and the cosine of the angle will be positive because it is in the x positive direction, because it is on the x-axis, which is in the positive way. And if we find the tangent of the angle, because the tangent of the angle depends on both sine and cosine, and one of them is negative, automatically this one will be negative. As in the case of negative 60 degrees, as we have done, we found that way. So this is the summary of the angles found in the quadrants. And if you do that, you will find the respective values of x, the respective values of sines, cosine, and tangent in the respective quadrants. Generally, for angles like having negative theta as an angle here, then it means if you find sine of negative theta, you will get negative sine of that angle. And if you find the cosine of negative theta, actually is the positive of that angle, is just cos theta. And if you find the tangent of that negative angle, it's the same as finding negative of tangent of that positive angle. So you will find that is the summary of negative angles. Let's see how we can find trigonometric ratios for angles greater than 360 degrees. And for this case, we may start with an angle which is 420 degrees. And we can say this angle, if we draw it on, if we map it on a unit circle drawn on a Cartesian plane, you will find out that the angle will overlap in that it will move one full rotation the other way up to that point, that is 360, and with an overlap of additional you will find it moves up to that point, and that is 60 degrees. So the angle will move 360 degrees, that is this way to that point and back to that point. So it has moved 360 degrees plus another 60 degrees to make it 420 degrees. From this point, it moves around that circle and then it comes back and with an overlap of 60 degrees. So you may find some of the angles which are greater than 360 degrees, they may move even thrice 360. So meaning 360 might multiply by 3, yeah? That means that it has gone round the circle thrice, meaning it has 3 rotations. So it's 3 multiplied by that, and then with another acute angle. That is what we are trying to overlap. So if we do that, you will just find that the angle, if we find the coordinate of that angle on a Cartesian plane drawn on a graph with a unit circle, whereby the radius is 1, 1, you will find out that you will have Let's call this point D. This is O, this is P, and this is always x-axis, so it will be like our x. So if we do that, we are going to have that one D or P, and P is in point of xy. We shall find that we shall have this way, whereby xy coordinate represent the x distance moved from O to D, and distance moved from P to D is represented by coordinate y. So if we need to find that one, and remember the hypotenuse is the same as the radius of that circle, which is 1. And if we need to find x and y, having this angle now at 60 degrees, we can say that if we need to find sine 420 degrees, is the same as finding sine 60 degrees for our case here. And that sine 60 degrees is the same as now, if you look at the coordinates here using a Cartesian plane, you are going to find that the coordinates here will give you 0.5 and 0.86, and on calculation you are going to get here, if you find out that one, you are going to get sine 60 will be y over 1, which means that for y equals to sine 60, because if you multiply both sides by 1, you are just going to get sine 60. So if you find sine 60 is going to give you 0.8660 to 4 decimal places, you are going to get that. And for the cos of that angle, cos 60, cos 420 degrees, is the same as finding sine 60 degrees, which is equal to, is the same as finding cos 60 degrees. And if we do find cos 60 degrees of this angle, it's just finding the x-coordinate, of which will be now the adjacent of that triangle, divided by the hypotenuse, which is our radius of the circle, which is 1. And if we do that, it's going to give us x is equal to cos 60. And if you do that, you're going to get 0.5 as our x. So we have found x and we have found y. If you relate the two answers which we have found, one which found on Cartesian plane when you draw on a graph, you will find is the same as that drawn and that calculated as a triangle than on the Cartesian plane. So if we relate the two answers, we shall find that that of drawn on a graph has similar answer with that of calculation. So from there we can say that if we find the tangent of 420 degrees, it's the same as finding the tangent of 60 degrees. And this one here we say it shall be, from this triangle we are going to have y over x, and y over x is going to give us, y over x is going to give us now 0.866 over 0.5. And remember, this one is the same as saying sine 60 over cos 60. So if you do that one, you are going to get something. Going to give you 1.732125 significant figure. So we have found out, in order to express an angle greater than 360 degrees, we do find out the acute angle which is almost equal to that angle, and then we express the angle which is greater than 360 degrees with its relevant acute angle. For this instance, 420 degrees we found it is a rotation of 360 plus an overlap of 60 degrees. Here 60 degrees is our relevant acute angle, and we express 420 degrees with respect to that overlap. And we have seen on a Cartesian plane and calculation how we do find it. We are going to see how we can use mathematical tables to evaluate cosine, tangents, and sines of different given angles. For instance, having been given an angle like theta equals to 132 degrees, and you'll be told to find the corresponding trigonometric ratios. So here, we shall find the sine of 132 degrees also cosine of 132 degrees, and tangent of 132 degrees using mathematical tables. You are required to have your mathematical table, and then you shall check under natural sines, natural cosines, and also under natural tangents. Don't go for logarithm sines, logarithms of tangents, and logarithm of cosine. Just check under natural sines, natural tangents, and natural cosine. So what you do, you will identify that if you have your mathematical table, you will find that it is divided into different kind of sections, and the first section is that the first box here, where it may be X or empty at the top, and there's some division. Then at this first corridor, you will find that here it's from 0 as it goes, 0 degrees, 1 degree, as it moves on. It is presented in degrees, be it of tangents, cosines, or for sines. You will find it is from 0 onwards. And then here we have been given 0.0 or even 0.0, and then that one has that line. That way it is divided into number of columns, and from there you will find out that this one is 0.0, 0.1, or it is 0.1 or just 0.1. It depends with the mathematical table you are using. Then 0.2, 0.3, as you move on up to 0.9 or 0.9. Then after that we have another column at extreme end where we have 1, 2, 3, 4, 5, 6, 7, 8, up to 9. Up to 9. Let me fix it. It's up to that 9. And you will find out that on this column you have been given degrees. This one is dot, so meaning it is point something, and then this one is another kind of the table. So as you move on, we shall see how we handle on. And for example, if we need to find cos of 132, we see this one can also be written, sine of 132 can also be written as sine 132 degrees, 132.00 degrees. Here now, this 0.00 degrees means that this first 0 will be located at the first table here, and the second one is located where the numbers is. So the last digit here simplifies the last part, and this first digit here after the decimal point simplifies this part here, the first table here. So the first column here, which is on the X, or it may be empty, that one, it is written in degrees, simplifies degrees or what you have, like 132 and so on. So if you want to find sine 132 degrees, what you need to do here, you need first to make it be an acute angle. We write it in the way of acute angle. And if we move this one, we write it in an acute angle. We found that if an angle lies in the second quadrant, to find that angle, we do take 180 degrees you subtract the angle which you have in order to find an angle that lies in, actually let us give it down here, but in second quadrant, if you need to find an angle which is acute in that angle, in that quadrant, then you will take your angle, you subtract from 180 degrees. You will find an acute angle equivalent to that angle. And in third quadrant, you are going to get 180 degrees. If you need an angle in the third quadrant, you will take 180 degrees, you add it to that theta, you will find an angle in the third quadrant. And if you need an angle in the fourth quadrant, is 360 degrees minus the angle you have. You will find an angle in the fourth quadrant. But for this case, we need to find the sine of 132, and we have said we need to make 132 in such a way that it becomes an acute angle. So we are going to make this one an acute angle, and to make it an acute angle, we are going to get 180 is the same as taking sine 180 subtract 132, and this one is going to give us sine 48. So if it is sine 48, what we are going to do here, this is the acute angle which we need to find. So we shall go to our table here, and then you move and look where 48 is present. So you will find at 48, we have 48 somewhere like here, 48 degrees, it's just 48. And you move across that point as you move right side using natural sine tables. So you move right hand, and you will find that this hours here is 0.0, it's just 48. So it will be 0.00, and the first value you find here, you record that value. For instance, for this one, I'm going to get 0.7431. So meaning that one 0.7431, that is the value of the sine of 48. And sine 48, we are getting is as the same as that of 132. So we find that sine 48 is the same as sine 132, and we are getting it to be 0.7431. If you need to find the cosine of that angle, it's still the same procedure. So you do cosine of 180 minus 132. You will find that you are finding the cosine of 48 degrees. And you will now use the table of natural cosines. For cosine, you use natural cosines. And if you use the table of natural cosines, you are going to get that 48 degrees will lie at the same place, for example, and then you use the graph of natural cosine to find out what you have. For example, if it is 48, you move up to a point where you will find 48.0, so it is at the first column. So you will take 48.0, that is 66, 0.6691, 0.6691. But remember, cosines and tangents in the second quadrant, they are always negative. So meaning that the angle here which you find using the mathematical table is positive, but you remember that the angle which we have as a positive or acute here is resemblance to that of finding cos 132 degrees, which is found in the second quadrant. But cosine is negative in the second quadrant, so this answer here should be negative. The same applies to tangent, and if we want to find the tangent of 132 degrees, it's the same as finding the tangent of, in the second quadrant we say is 180 minus 132 degrees, so as to find the acute angle which is equivalent to that. And on doing that, you will find that you are finding the angle which is the tangent of the angle 48 degrees. And if you do that, you are going to use now here, you shall not use the natural cosine, but now you are going to use the natural tangents. So meaning what you will be now using is the natural tangent. And if you use the table of natural tangent, you shall go where 48 degrees on the x there, where it is, then you view where it is 0.0 degrees, and review the answer which you will find under the table of natural tangent. And you will find this one here is going to give you 1.1106, and this one here is the value of tan 48 degrees as an acute angle. But remember what we said. This is an acute angle in the first quadrant, but it is a resemblance of the same tangent of the angle of 132 degrees, which it is in second quadrant. And in second quadrant, all angles of tangents are negative. So meaning this, our answer here is equal to negative. So meaning tangent of 132 degrees is equal to negative of this, what we are finding here. But if it was an acute angle 48 degrees, then the tangent could be positive. So that is how we calculate using mathematical tables. If you calculate using mathematical tables, remember to take consideration of the quadrants in which the angles lie. And take note, remember where the tangents are positives, cosines positive, and also the sine positive. So take that into consideration when you are calculating using mathematical tables. Whereby you have been provided with, you have been told to find, solve for x, solve for sine x equals to 0.7124. 0.7124. If you have been given this one, using mathematical table, you need to solve this one. What you should do here is, we need the angle. We don't have the angle. So what we have been given is the sine of that angle after finding it. So what do we do? You will go to the table of natural sines. After getting the table of natural sines, then you shall now view where you find 0.7, 1, and so on. So using the table of natural sine, on viewing you will find that 0.71 lies within the column of 45 degrees. Within that column you will find, if you have here 45 degrees, you will find 0.7. The first one is 0.40. Here, you are going to get 0.7071 for 0.1, meaning that if it is 45.1, you will have 0.7083, and so on up to where we have 0.724, 20 actually. So the one you will find one of it which is close to our 0.7124. And for this case, if you move across that column which I have told you that is 45 degrees, you will find the one which is close to our value here is 0.7120. And this one lies under the column of 0.4. Actually, it's under the column of 0.4. So meaning that we have 45 degrees, but this one is lying under the column of 0.4. So it is like 45.4. So if you have 45.4, you will check under 45 and then you go where 0.4 is and you come, you will find your answer here is lying between 0.7120. Then if you take 0.7124, you subtract 0.7120, I mean, if you take 0.7124, subtract 0.7120, you are going to get 0.0004. So we are going to get this value, but this value are being represented at the extreme end, and they are only represented at these values only. As all numbers 4, you may find 9, like 10. 10 means now, if you find a number represented as 10 in the last column, I mean in this table now here, you will find it is represented in form of 0.10010 if it is 10. But if it is a single number, it is 4 decimal places. Like that, if it is 4. If it is 5, this is 5. If it is 6, this one turns to 6. And if it is 7, so on, that is how it changes. So we are going to find out where 4 lies along that column. Since we have found it is within the column, the row of 45 degrees, so we are going to see where 4 lies along that one, and we are going to find 4 is along the column of, you will come and find the 4 is along this column of 4. So the way the 2 meets, the row of 45 degrees and the column of 3 meets, you will find it meets at 4. and that's what we are taking. So, meaning that we shall have 3. So, here we shall add 3. So, we have found that if you find the sine of the angle, now our x here, this is what we are referring to x. So, our x here is represented by 45.43 degrees. And if you need to find the angle of that, the sine of that angle, is better like doing 45 degrees, then you move to the column of 0.4, whereby it is here. So you will find 0.7120, 0.7120. Then you move to the last digit, which is 3, and the last digit is in the last column, last table. So you move up to 3. So you find where the two coincides. You will find it's at 4. And as I said, if it's a single digit, you will find it is represented in 4 decimal places. So it will be 0.4. So you add the 2, and you will get back to 7124. And that is what we were provided with. So x here is equivalent to 45.43. And we have seen how you can find natural sines, natural tangents, and also natural cosines of given angles using mathematical tables. So meaning that in any of the position, if you have been given an angle of decimal or just angle without the decimal, you can still find the natural sine, you can still find the sines, cosines, or the tangent of those angles. And at the case, if you have been provided with an angle in minute, for example, you may be provided with an angle like you have been told the theta here is, for example, let's say 50 degrees and 36 minutes. Here, what you should do, we know 60 minutes make up 1 degree. So, meaning that if you need to know how many degrees are there in 36 minutes, then you shall now take 36, you divide by 60, of which this 60 minutes is equivalent to 1. This one is equivalent to 1 degree. So if doing this, you will be finding the number of degrees you have. So doing that way, you are going to get 6 here, 6, 10. So 2, 3, 2, 5, and this one is going to give you 0.6. So you will find you are going to calculate the angle now turns to 50.6 degrees. Now you can use now 50.6 degrees and locate it on any of the graph, be it of tangent, cosines, or sines. You can now use any of them. Using mathematical table, I believe now you can find the tangents, sines, and cosines of different given angles. And also, if you have been given those natural sines, or you have been given the tangents or sines of the angles, you may find the angles with the respective sine or trigonometrical ratio. Let's see how we may use calculators to calculate sines, tangents, and cosines of given angles. For example, if you have been given angle like 30, we can calculate tangents, cosines, or sines of that angle using a calculator by, if it is 30 degrees and we need tan of that 30 degrees, then it means if we do that, we are going to get, you will first key in tangent key, whereby you will find on a calculator. For mine, I'm using FX82MS, Casio Limited Company, and you will find that the tangent of that angle 30, I will key in tan key, and it will display that tan on the, it will display on the screen. So after that, I will key in 30, just 30. If I key in 30, the calculator will know that I have directed it to calculate for me tangent of 30 degrees. So if I key in 30, I will find that the calculator writes, actually it writes tan 30. Then after that one, you key in equal sign. And if you key in equal sign, you are going to get that it will display 0.57735 and so on. So you round off to 4 decimal places and you will find is 0.5774 because it's displaying numerous numbers like 0.75735026 and so on. So you round off to 4 decimal places and you will find that the tangent of 30 you are getting is as 0.5774. And if it is cosine of 30 degrees, you will find out that cosine of 30 degrees, you only key in cos t on the calculator, and you will find that the cos t on the calculator is present. If you key in, it displays that cos key, and then you key in that 30, meaning you press 3 and 0. So if you key in 30, you will find that the screen displays cos 30. And if you just display that way, the calculator just automatically knows that you want to find the angle 30 degrees, the cosine of 30 degrees. So after doing that, you now key in equal sign and you will find the screen displaying 0.866025403, but we need to round off to 4 decimal places, so it will be 0.8660 because this one is not greater than 5. So we shall find this one as the cosine of 30. Let's find sine of 30. Then you need to key in sine key. If you key in sine key, you will find the screen displaying sine. And then after that, you key in or press in. You press 30, that is 3 and 0. You will find your screen displaying. Screen will display sine 30. And automatically the calculator will know you want to find the angle, the sine of the angle 30 degrees. So after that, you key in equal sign. And you will find out that on keying in equal sign, you'll find the calculator will display 0.5 on each screen. That means that the sine of angle 30 degrees is equal to 0.5. So that's how you can find the tangent of any given angle. For example, if the angle is theta, that is the same procedure you will use to find the tangent of that angle. And also you can find the sine of the same angle and also the cosine of the same angle with the same approach as I have guided you. It doesn't depend on how great the angle may be. So if you have, for example, you have an angle with the decimal, for example, like 42.45 degrees, the same applies. If you need to find the sine of that angle 42.45 degrees, you just key in the digit you are having and then you press the equal sign. It will automatically give you the answer. For this instance, you will find that the sine of 42.45 using a calculator will give you 0.6749465554. Then after doing that, you just round off to 4 decimal places and you will find it is 0.675, actually 4.549. This is 4.9 because this one is not greater than 5. So it's 4.9. So you shall find it is at that point. So meaning you can find any given sine, tangent or cosine of any angle using a calculator. On the other hand, you may be given that find the angle theta. Find angle theta, for example, sine theta equals to, you may be provided with 0.7660. Now this is not 0.8660, this is 0.7660. So you are being asked to find the angle theta here. using a calculator. What you do now, you will go to your calculator and instruct it as you want. For example, you will key in shift key, which is located on top of the calculator in most calculators. Then key in sine key, and if you key in sine key, you will find the calculator displays sine inverse. That one displays that way. Then you key in this one. Key in now 0.7660, and you will find on keying 0.7660, you will find out that after doing that, you will find your calculator will display the same thing. Calculator displays sine inverse 0.7660, and after doing that, you now key in equal sign, and on keying in equal sign, you will find the calculator displays 49.99603866. And if you round this number to the nearest whole number, or let's say to two significant figures, you will find it is 50. Because this is 9, and if you round off, it will give you 50. So if you find the sine of angle 50 degrees, you are going to get what we have here. That's how you can use calculator to find the inverse of any given angle, and also to find a cosine or sine of any given angle. So meaning that to find the angles or trigonometric ratios using a calculator is simply very easy to use it if you know how to operate a calculator. We are going to check and see how we can find radian measure. And from this section, we have seen in our previous session that we were dealing with the angles which were in degrees. And now we are going to introduce another unit of measurement of an angle which we call radian. And this one here, we shall have it as, we shall consider a circle whereby it has radius r. And we shall say that if this circle having an angle theta and moves, for example, if one moves in that direction or either way and covers a length equal to the radius of the circle, that is the circumference equal to the radius of the circle, then the angle subtending that length or the arc covered is what is referred to as 1 radian. 1 radian, denoted at 1c, or let's say theta c. So, the angle which subtends an arc equal length to the radius of the circle is known as 1 radian, denoted as this, and is read as, if denoted as theta c, then this one is theta radian. That is how we read it. And if it is 1 radian, we do call it 1 radian. That's how we write them. So, having that one we have seen, that is the angle, and we know one thing, that all the angles in a circle measures up to 360 degrees. And one thing we also know that to find the circumference of a circle is equal to 2 pi r. That is how to find the circumference of a circle. The total circumference of a circle is 2 pi r. And we also know that from what we have just said is that the circumference here, which we have here, is r. We are having an arc length equal to r. So if r is our arc length and is equal to 1 radian, then what does 2 pi r radian represent? Or what does the whole circle represent? We need to know how many radians are there in the whole circle. If one moves along the circumference of the circle, how many radians will that person have covered? So if we do that, we are going to get 2 pi r multiplied by 1 radian over r, and this r will cancel with the radius, so we are going to get 2 pi c. So we see that in a circle, a full circle, we have 2 pi radian. So we have found out that in a full circle we are having 2 pi radian. So we shall say this. We can now identify out and say, if in a total, or the angles in a circle, they all add to 360 degrees. What does 1 radian represent? So we shall take our pi as 3.142 and say that if that is our pi, and we do know that the total of this circle represents 2 pi radian, and we know that 2 pi radian is equivalent to 360 degrees. What about 1 radian? So we are going to look about 1 radian, and we shall see that if we need to find how many degrees are there in 1 radian, we are going to divide it by 2 by pi radian, but this pi we have said is to be 3.142 radian, so we shall find radian and radian which cancel out, and we are going to get, you are getting 57.28835,137 using a calculator. So if you round off to 4 decimal places, we are going to have 57 point. Actually, if we round off to 4 significant figures, let's round off to 4 significant figures, we are going to have 2.9 degrees there. So we have witnessed that 1 radian, which is the angle subtending an arc length equal to the radius of the circle at the center, we are seeing it is 57.29 degrees. We shall use this relationship to calculate different angles as we move on with the radian measure theory. So let's see how we can find it out. We have been told convert 135 degrees into radian. Convert 135 degrees into radians. So if you have been asked to convert 135 degrees into radians, what you do here is you relate what we have there. So we shall say if 57.29 degrees, we have found it is equivalent to 1 radian. What about 135 degrees? How many radians will be present? So we shall do cross multiplication, and whatever we are going to get here is 57 actually will be 135 degrees multiplied by 1 radian divided by 57.29 degrees. So whatever we are going to get there is what we shall refer to the radians of 135 degrees. So I'm getting 2.356432,187. And if I convert it or I round off to 2 decimal places, I'm going to get 2.36 radians. So that is what I'm getting at that point. So we can say if you convert any angle into radian, what you do, you only relate the relationship that 57.29 degrees is equal to 1 radian. What about the angle you have? What does it represent in radians? So after doing that, you will find the number of radians you want. So we shall check up another example. And our next example is convert into radian, leaving your answer in pi. Convert into radian, leaving your answer in pi. We have been provided 60 degrees. if we have been asked to convert this 60 degrees, leaving our answer in pi, then we shall say it this way. We all know that angles in a circle, they all add to 360 degrees. And we also found out that this 360 degrees is equivalent to 2 pi radian. Now we shall ask ourselves, if we have only 60 degrees, what does it represent in pi radian? So we shall equate that one and we find out what does it represent. You will find out that if you take 60 degrees multiplied by 2 pi radian, you are going to get, and if you divide it by 360 degrees, you will get that you are going to get a third pi radian. So if you convert 60 degrees into radians and you leave your answer in pi, you are going to get your answer will be a third pi radian. So another one you have been given here, you may encounter another question involving like an arc subtends an angle of 0.9 radians if radius of the circle is 13 centimeters. Find the length of the arc. So you have been given a circle. You have been told radius of this circle is 13 centimeters. And then you have been told that an arc subtends an angle of 0.9. So let's say here is 0.9 radians. So you have been asked to find this arc length. Actually, the radius is 13 centimeters. So you need to find this arc length. Remember one thing. We did say that an arc length equal to the radius of the circle subtends an angle of 1 radian at the center of that circle. So, if it were that this was 1 radian, then it could have subtended an arc length of 13 centimeters. Meaning that if we had the radius of the circle, the arc length here being the radius of the circle, we could have found 1 radian. And the radius of the circle could be 13 centimeters. Now could be have subtended an arc length, an angle at the center of the circle of 1 radian. But here we are having something which represents 0.9 radians. The arc length subtended at the center of the circle we are having here is 0.9 radians. So what length does the arc covers? So we shall cross multiply and we shall find that you will find 0.9 radians multiplied by 13 centimeters divided by 1 radian, and you will find out that this one is the same as writing 0.9 radian, and you will have your answers 13 multiplied by 0.9, and you are going to get 11.7 centimeters. So the arc length subtended at the center of the circle by an angle of 0.9 radian is 11.7 centimeters. We are going to see some simple trigonometric graphs of this kind of functions. For example, we shall be seeing y equals to sine x, where x is between 0 and 360 degrees, and also y equals to, let's say, cos x, and y equals to tan x. All of this we shall see them under the range of 0, x, 360 degrees, and with an interval of 30 degrees each. We shall see how we can find it. So we shall start with the y equals to sine x, for x within the interval of 0 less than x less than 360 degrees. Then from there, we shall draw it with an interval of 30 degrees. So what we shall do, I'm going to form a table of x and y equals to sine x. Y equals to sine x. So we shall form it. So, if we draw a table of y equals to sine x, we are going to get that the values of x with the range of intervals of 30 degrees, we shall find they will relate with the graph I have drawn at this point. So, you will find it in that way. And if you plot the graph on a Cartesian plane, you will find out that on plotting and drawing the graph of y equals to sine x, you will find it being like the one I have drawn here. So you find that it originates from 0, starting at 0, 0, so it starts at the origin. Then it is within a series of 108 actually. At 180 degrees, it is x equals to 0, and actually at 180 degrees, y equals to 0, and also at 360 degrees, y equals to 0. So meaning, its full amplitude is from here to here, which is 1 unit. The same to downward part from here to here is 1 unit, and we can see it's 1 unit if we compare that point. So we are finding out that the amplitude of y equals to sine x is 1, and also the period of that wave is 360 degrees. That is the period. So we have found out that way. So we shall see another relationship for a graph of cos x, as we shall do it later, with an interval of 30 degrees, and also range remains the same. Now we have seen we have y equals to cos x with an interval of 0 degrees to 360 degrees. So I've been doing that through an interval of 30 degrees, and I have found the value of y equals to cos x with regard to x given as 0 degrees, 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150, and 80 degrees, and so on up to 360 degrees. So I have found the respective values, corresponding respective values of y equals to cos x, and on plotting the graph, you will find, if you plot it on a Cartesian plane, you're going to have a graph which resembles what I have here. So this is what I'm referring to, y equals to cos x. We saw that of y equals to sine x, we saw it giving us actually a sinusoidal wave. But this one is still the same, but this one, look at the way it is. It's just like one trough. And from this we can identify that the maximum displacement in vertical direction, the maximum vertical displacement of this wave, it is 1 unit actually, meaning the amplitude of the wave is 1 unit, and the same applies at this point. So that point is only also 1 unit. If you may view it well, you will find it is 1 unit. So we can say that the maximum displacement of the wave is 1 unit, and also, if you may view very well, you will find out that at 90 degrees, meaning that if you find cos 90, you will find at 90 degrees cos 90 is equal to 0. And at 0 degrees where it starts here, you will find cos 0 is 1. So meaning cos 0 is 1. and cos 90 degrees is 0. Cos 180 degrees, you can see from this graph, it is -1, and cos 270 is 0, cos 360 degrees is 1. So meaning that if we start, for example, from this point, and we move to that point, we have covered a half, and if you come back to 360 this point, whereby this is the crest where the turning point starts, you will find the graph covers one complete period. So the period of this wave is 360 degrees. But remember one thing we have said, at instant points you will find that the cos of a given angle is -1, another one is +1, and for 270 and 90 degrees we have found the cosine of that cos x at that point is 0. So we shall see another one which is tangent of x for given period within 0 degrees to 360 degrees in intervals of 30 degrees. Now we shall draw a graph of y equals to tan x for intervals between 0 degrees to 360 degrees, and in my intervals I will use of 30 degrees intervals. So I will find out, if I will find out it to be up to that instant point. So on drawing, I will find, if I draw a graph on my Cartesian plane, I'm going to find out the points will be located as they are, but the graph is not as smooth as it should be. So what I'm going to find out is that if I draw out, I'm going to have a graph which passes there, but as it approaches that point, it becomes as if it is parallel to it. It comes much more close to that of line 90 degrees, but it doesn't touch. So you will find again from infinity as it goes that way, and again after reaching 270 degrees you will find again it comes from infinity as it moves, and the process continues that way. So this graph here which I am having is y equals to tan x, where x is within 0 degrees to 360 degrees. So as we can see, here we are seeing that this is not a smooth graph. We are seeing that the graph starts well from 0 degrees, then as it approaches 90 degrees, you will find out that it is vanishing. The lines are vanishing or going to infinity. And at the point where the lines are not touching that of, the graph is not smooth or touching the line of x equals to 90, we can see that at that point we do say that the graphs or the points are undefined, and with that we can say at that point actually is not touching actually at 270 and at 90 degrees. So these points are undefined, so the graph looks as if it's parallel, then originates from infinity and negative infinity again to positive infinity as it continues that way. So you can find the values of given x here using the tangent. This is my graph of y equals to tan x. You can find the values of x, any kind of x, if you have drawn to scale, so long as it's not 90 degrees or 270 degrees, because that one will give you infinity. The points which are undefined are represented by a letter which I write as infinity at this point. So with that we have seen how simple trigonometrical graphs are being drawn. We started with this y equals to sine x and we saw how it looks like, and y equals to cos x. We are now finishing with y equals to tan x, and you can see how the points are behaving. We are going to see how we can find that we can give solutions of a triangle using cosine rules and also sine rule. For this instance, we are going to start with the sine rule. And for this, I'm going to start with a triangle which is acute, have acute angles like that. So I assign this side A, this one B, and this one C. And for instance, if I assign that way, we give it a condition in that the side which is opposite to the vertex of that angle, or the other triangle, the vertex, then that side we assign it later equivalent to that angle. So this means this side will be assigned A, the other one C, and the other one B because it is opposite to the angle B. So if we need to find the area of this triangle, then it means that the area of this triangle can be found in three ways. And the first way here, we can find area 1 with what first reference by taking a half multiplied base multiplied by height, as it is the formula for finding the area of a triangle. And this one we shall take our first base as BC. If we take BC as our first base, we know BC is equivalent to A. So if that one is equivalent to A, then we are going to write there A, and then we multiply by the height, and our height here we need to identify. So meaning if we need height, we shall draw here a perpendicular. And if we draw there perpendicular to meet BC at certain point, then it means this will be our height. And if we find what does it represent, we shall say that if we take now, if we need the angle C, for instance, if it is angle C here, we shall take, or let's say we need angle. Let's just use C. We say if we need sine C, then it will be the opposite because this is a right angle triangle. The opposite of that angle, which is H, now over the hypotenuse, which is B. So our H here is equal to B sine C. Now we can write our equation a half multiplied by A, but in place of H, we replace it with B sine C. And we shall find, if we do that, the area here is being given as AB sine actually C, so, but it is over 2. So that's what we found as area 1. Another way of expressing the area of that triangle, we may now, instead of taking BC as the base, we may take AC as the base of that triangle. And if that is the case, we shall find the area as a half multiplied by base multiplied by height. And in so doing, we are going to have a half multiplied by the base, and we say, let's take the base to be B. If the base is B, then the base is AC. So if it is AC, we shall have B as the length of that base. Then we multiply by height, which we don't know. But for that case, we need to find the height. So if you construct a perpendicular bisector to line BC, to line AC, I mean, you will find that the line, the height of this one, the height of that triangle, you may calculate it in different ways, in such that you may decide to use now A as our angle there. So if we say we use that A as our angle, so it means that if we need the sine of the angle A, we may find that sine of the angle. Since this one is a right angle triangle, we shall say is that opposite of the angle over hypotenuse, which is over C, and meaning that if we need H, we shall now take C multiplied by sine A. So meaning here, in place of H, we shall write it with substitution of H as C sine A. And we find out that we are going to have a half BC sine A. So after getting that, we can do the same. We can do the same area in the third dimension by taking side AB, actually side AB as the base. And if we do that, we are going to get the same area but in different approach. So we are going to have a half multiplied by base, and we are taking the base to be AB. So AB is equivalent to C as our base, multiplied by height, which we don't have for now. So if we need the height, we are going to construct or to drop or to bisect the line, and we shall find it will drop a perpendicular to meet line AB at a certain point there. So if we do that, we are going to have our height as this. So if we need that height, we can use this side, this angle to find that height. And if we do that, we shall find out that if we find the sine of the angle B is equivalent to H over A, because for this angle here, angle B here, we are having an opposite side to that angle as H, and the hypotenuse of that angle is A. So if we do that, we are going to have H is equal to A multiplied by sine B. So that if that is the case, we are going to have a half C, actually it will be a half multiplied C multiplied by A sine B. So if we do that, we are going to get a half CA or a half AC sine B. So with that, we have found the areas of the triangle with 3 different ways by considering each side of them as the base of the triangle and constructing a perpendicular to meet a certain given base so as to find the height of that triangle. So we have found. And with that, we can still equate the areas and say that if we take area 1, it should be equal to area 2, which should be equal to area 3. Since from this dimension, we can say that the areas are the same because we were using just different bases of the same triangle. So if we do that, we are going to have the first one, we had AB sine C over 2. That is for A1. And then A2, we got a half AB, also a half, it was a half BC actually, BC sine A. And the third one was a half CA sine B. At that point, we can decide now to divide both sides. Divide it through by a half. Now you divide through by a half ABC, so as to remain with what we shall find. And if we do that, we shall find, if you divide through by that one, we are going to have that one as AB sine C over, now it will be, if you divide by a half, you will find it is 2 ABC is equal to 2BC sine A over 2ABC, which is equivalent to 2CA sine B over 2ABC. So if we do that, that is what we are going to get if we divide through by a half ABC. So we are going to cancel those which looks alike or the like terms actually, and we shall remain with the sine C, sine capital C, which is sine of that angle C, over C is equal to, now cancel out 2 and 2, BC, and we remain with the sine A over A, which is equivalent to, this one cancel itself, so we are going to cancel here C and C, A and A, and we shall remain with the sine B over B. That's what we are going to have. So as you can see here, we find out the reciprocal of what we have, and whatever you will find is what we refer to as sine rule. What do I mean? If you find the reciprocal of C sine C, we are going to have C over sine C is equal to A over sine A which is equivalent to B over sine B. And this is what we refer to as sine rule. And you can use it for any given triangle so long as they are the dimension we are mentioning here, and you will find out whatever you are seeking for. Now let's consider another one whereby we have a triangle, two triangles actually, which are different from what we had there. Then we have A, B, C with this extrapolation as D, and this one touching here as E. So from this, as we have done earlier, we can give sides to each of them, and we shall identify this side from this direction up to C, meaning base BC will become our BC becomes A, small a, and the opposite side of B, which is AC, will be small b, and the other one will be C. So another triangle may be included. This one is for acute angle. So we need to draw another one for obtuse. So on drawing we shall have, so on drawing also this one will be A, this one might C, this one B, but if we extrapolate to make this one like right angle triangle, we shall find out at the point here may be E at that point. So if we need to handle out, we shall start with this one. We need to find the sine rule, and from that one we can handle that with respect to AB, and we do say that if we need AB, we can find it with the angle AC, the angle C actually. So we shall say to find angles, which is sine C, is equal to, now we have the line which we make this one is a perpendicular, so we shall have a triangle ABC. Actually it's ADC, so we are going to have a triangle of this section. With this side we have been provided with B, this is ADC. So this is what I require, this side AD. So what I shall do, I'm now going to use trigonometric ratio, whereby I'll say to find sine C, which is the sine of this angle. Now I'm going to take the side AD, which is the opposite of the angle, then you divide by the hypotenuse of the triangle. And if you do that, you will find it will be over B. So meaning line AD or side AD is equal to, you multiply both sides by B and find line AD is B sine C. Now you can still find it using the other way around, in that instead of using the other side, you use the left hand side. And we do say that to find that still AD, this AD, we can reverse and use another kind of an angle of the same, which will give us the same line AD. And if we do that, we are going to get this is A, D, B, and this is C. So we are going to get something like that. And we need to find line AD. If we now need to find that line AD, it means that now our AD here, let's say angle B, the sine of that angle B is equivalent to line AD divided by C. That is the opposite of the angle, which is AD, divided by the hypotenuse of that angle, which is C. And on doing that, this small c, so on doing that, we are going to get that AD here will be equivalent to, if you multiply both sides by C, you will find out that C will cancel and you remain with the AD is equal to C sine B. Now we have found BAD having two identical, it's having two length or two, actually it's two length, but are of different from different used angles. So we shall equivalent because line AD is still the same. So meaning whatever we found using whichever method is the same. So meaning that if we take this AD is equivalent to this AD, meaning that B sine C is equivalent to C sine B. Now here we are going to divide both sides by, now this is sine C, so we shall divide by sine C and also by sine B. We are dividing both sides by sine C, sine B. The same should apply to this side. And we shall find out that sine C here shall cancel with this one, and we shall remain with B over sine B is equal to, now here sine B cancels with the other sine B, and we remain with the C sine C, which is still the same as what we were finding earlier in trigonometric or in sine rule using the other triangle of acute angle. So we have seen that, and still we can use the other triangle there and find the same thing. I will just redraw that triangle here up there so as to use it well. I'll find out that if I need AD here, AD, I can find it in a different way, and I will find it that it will be, AD will be equal to, now I'll be using this angle here, and if I use that angle, I'm going to get AD is equal to sine B, using the triangle ADB, so I'll get AD over, actually let's just use all of it, so we shall say sine of that angle, which is sine B, is equal to, sine B is equal to AD over hypotenuse of the triangle, which is C, and we shall find that AD is equal to C sine B, whatever we just find in the previous one. So we have found out that using that triangle, we found out that A over sine A equals to B over sine B, which is equal to C over sine C. But what we know is that if you circumscribe, for example, if this is our triangle which we had, and this was A, B, C, and in case this was C, actually this is B, this is A. If you circumscribe, circumscribing is you pass a circle, you draw a circle. If you circumscribe that way, whereby A, B, C we have here, and this is side C, B, this C, and this A. If you circumscribe that circle, you will find out that whatever we have done here, any of them is equal to 2R, 2 of the radius. If this is the center, you circumscribe using. So you will find, if you work out this way, you will find that it is equivalent to the diameter of 2. This formula, as we have in here, works for any triangle you have been given, so long as provided 2 sides and 1 angle is included, and also all sides and at least 1 angle if you have been given, and if all angles and at least 1 side of the triangle are being provided. For example, we shall see how it works with an example. We shall use this in triangle PQR. Calculate the values of P and Q if angles R is 43 degrees, Q 61 degrees, and R 5.1 centimeter. So we shall draw the triangle in case we have here, like we shall just draw any of them. Then label this P, Q, R. After labeling, we have been told that angle R is 43 degrees. So this angle here is 43 degrees. And also we have been told that angle Q is 61 degrees. Q here is 61 degrees. Then we have been informed that R is 5.1. So if this is R, we said the opposite side to it should be small r, and this one should be P, and this one should be Q. So if that is the case, then we have been informed that small r is 5.1 centimeter. This one is 5.1 centimeter. Now, using that one, we can say that we can find the value of Q actually by using the same formula, whereby we say if we have this side, if we have this side R, over the sine of the angle R, which is this, should be equal to the side Q over the sine of the side Q, which is now this angle. Now, this one also should be equal to P over the sine of the angle P, which we have at this point here. Now, that's what we are going to do. We need to find it that way. So, what we are going to do here, we are going to substitute for the values of the unknown which are present here. For this case, we are going to substitute small r by 5.1 centimeter actually over angle R is 43 degrees, and this one should be equal to Q, which we don't have, over angle is sine Q. So if we do that way, sine Q actually is sine 61. So if we do that way, we are going to cross multiply so as we may find the values of one of them, and we shall find out that this one will be 5.1 multiplied by sine 61 is equal to sine 43 multiplied by Q. So whatever you will do here, if you want the value of Q, you divide both sides by sine 43 and this side by sine 43. If you do that way, you will find that you are going to have Q equal to, now the other one you use a calculator. So you will say 5.1 divided by sine 61. Then you press equal sign, and then the denominator one you put into bracket. You put divided by and then the denominator into bracket. So you will have sine 43. And after doing that, you will get your answer as Q is equivalent to 8 point, actually it's long. So Q is equal to 8.550028985 centimeter. But to two decimal places, you will have Q as 8.55 centimeters. So we have found the side Q, this side, we have found as 8.55 centimeters. Now we are going to find, we have been told also to find the side P. To find P, we need this angle, but we don't have for now. The same, we don't have the side P. So what we are going to do, since we have this angle 43 and the other one 61, and we all know that the angles in a triangle, if we sum them together, we shall get 180 degrees. So meaning that if we take 180 degrees, we subtract what we have here, that is 61 plus 43, we should get the angle which we are looking for, and is P. For that instant, we are going to say 180 subtract, actually this is 104, you will get 76. So meaning that the angle is 76 degrees. The angle P here is 76 degrees. Now we have found the angle there. So meaning we can use the same procedure there to find out what is the value of P. So if we do that way, we may relate with the n of what we want. For example, we may even take this r and say that if r is 5.1, let me use another probably here, and then we use. So we shall denote this. Since r is 5.1 centimeter and sine r is 43, so it is sine 43. And then this one should be equal to p, which we don't know, over sine p, and p we got is 76. So if you do that, we are going to find that it will give us sine 43 degrees is equal to 5.1 multiplied by sine 76. On doing that, if we want to find the value of p here, we are going to divide both sides by sine 43 degrees and also this side by sine 43 degrees. So we are going to have p is equal to, p I'm getting p is equal to 7.2558945 So if it is to 2 decimal places, I will get 7.26 centimeters. Now we have found the value of p and also the value of q using the same process, and that you can use it to find even the radius of a circle if the triangle is circumscribed in a circle. So using the same sign rule, you can find out whatever you will be requiring, so long as you have been given the condition such that you have either the 3 sides with the 1 angle present or 2 angles with the 1 side present, as we have seen, or you may have 2 sides, actually 2 sides with the 1 angle inclusive. So if you have that one, then end of the formulas here, whatever you will choose will work out. And first we are going to derive the cosine rule, and then from there we can use it to evaluate different triangular problems and see how we may find the solution to those problems. Here we may be given some of the 2 triangles. For example, we may have a triangle of this section, whereby this side is A, this B, this C, and then this side being A, this one C, this B. From there we may cut this triangle into a section like that, and we shall find, for example, the distance from this part to here is y. So meaning the remaining distance from this part here to here, where this one ends, is a minus y. And here is the height of our triangle. For the case if we want to find c, because this is like a right angle triangle as we can see, if we want to find the value of c, what we should do here is to find c, then we are going to square first. Using Pythagoras theorem, we shall say c squared here. Actually, let me cut out so that it may be clearly seen. I'm cutting out triangle. Let me give this one d, letter d, so that it may be. This is what I'm cutting out. So I will have triangle A, D, B with the side C, H, and A minus Y. So from there, I want to use Pythagoras theorem to find out what is the value of C. If I do that way, I'm going to have that C squared is equal to, now C squared will be A minus Y as the side of this part, then I square it, then plus the height squared. So on doing that, I'm going to have, if I square this one, I'm going to get A squared. If I expand the bracket actually, I'm going to find minus 2ay plus y squared plus h squared. This is my c squared. But at the same time, we can still find AB using the other remaining part of the triangle. And if we do that way, we are going to have, if I cut that one, we are going to have a side which looks this way. So whereby this is line AD, which is perpendicular to BC, and we shall find it at, as this one is B, actually this is C, so this is B, this is Y, and this is H. This is a right angle triangle. So I can say that to find B here for this case, now to find B, the hypotenuse of the other triangle, B squared is equal to, actually B squared is equal to H squared plus Y squared. You will take, to find the hypotenuse, you do take H squared, which is the height, then you add to Y squared, which is the base, and you will find B squared. This one, what we are doing here, we are doing whatever we are calling Pythagoras. But remember, here we have Y squared plus H squared. And here we have H squared plus Y squared. So meaning that we can replace C squared is equal to A squared minus 2AY. Then in place of Y squared plus H squared, we are going to replace it with its value, which is B squared. So we shall replace it by B squared. On doing that, we now need to remove this value here, and on removing it, we shall say, if we need, for example, the cos of angle C, let's take the cos of angle C. So we shall find out that if we need the cos of angle C, we are going to get that cos of that angle will be equal to, now we shall take H over, actually the cosine of the angle will be Y over B, because cosine is adjacent over hypotenuse. So the cosine is going to be Y over B. So if we do that way, we are going to multiply both sides by B in order to find the value of Y. After doing that, we are going to find that Y is equal to B cos C, where C is the angle and Y is the base of that triangle. So we are going to rewrite our equation here. C squared is equal to A squared minus 2A, but in place of Y, I'm going to substitute it with whatever I found here, which is B cos C. Then I finish with the plus B squared. On rearranging, I will have C squared equals to A squared plus B squared minus 2AB cos C. So whatever I found there is whatever we refer to as cosine rule. If you work out for the others too, you will find if you need B squared, in case you make that one the subject of the formula, you are going to get it will be A squared plus C squared minus 2AC cos B. And if it is A, then you shall have A squared is equal to B squared plus C squared minus 2BC cos A. That is how these things do work out. And if you work out using the same formula, you will get out whatever we have. Using the other triangle, which is obtuse, you will still get out the same values which we are getting up here. Having this triangle as A, D, C, B with C, D, Y, then you will find that if you find AD in first place, you will find out it's equal to AD. Let's first not find even AD. Let's just assign it as height. So if we need C squared or C using the Pythagoras theorem, I'm taking triangle ABD. So I will have C squared is equal to, now I will take the height squared and this base. So my base will be the distance from here to here plus the other distance. So I'm having A plus Y squared plus H squared, which is the height. Now on expanding, I'm going to have C squared is equal to A a squared plus, if you expand this one, you are going to have 2ay, then plus y squared plus h squared. But remember, to find b here, but b by Pythagoras theorem, you will find that b squared is equal to now h squared plus y squared from this triangle here. You will find out that b squared is equal to h squared plus y squared. Now I'm going to replace the value of h squared plus y squared by b squared in this equation. So I shall write c squared is equal to a squared plus 2ay plus y squared. Now plus y squared plus h squared. These two, we have found out that they are equivalent to b squared. So we shall replace it by b squared. And if we do that, we are going to have whatever we found there. So, but remember here, if we do out the cos of this angle C, we are going to find that cos C is going to be actually y over this b, so it will be y over b. And if we do that one, we are going to have our y is equal to, you multiply both sides by b, and you are going to get our y equals to b cos C. If you find that one, we have just found what is y. But remember, this is for the extrapolated triangle. But whatever we need here is now this supplementary, actually the angle which we choose inside, which is of ACB. Now to find that angle ACB, which we need, now we may say the cos of C in this triangle ACB, we shall have it as, because this one is supplementary angles with the other, then this one will be negative y over b. We shall have negative y because it's a supplementary angle of that one, so it will be that way. And then we shall multiply both sides by b to obtain the value of y. So we shall find b cos C is equal to negative y. If you need y alone, divide both sides by negative 1, this side by negative 1, and you are going to get that y is equal to negative b cos C. Now, since we have found y equals to negative b cos C, you need to come back to your equation here and replace the value of y. So on replacing the value of y, we shall find out that c squared on that equation will remain a squared plus, now on replacing this one here will be plus 2a into negative b cos C, then plus b squared. If you rearrange this one, you are going to get c squared is equal to a squared, now plus this b squared. Here negative, if you multiply through, we'll check this number to be positive, so you're going to have minus 2, actually 2a b cos C. And if you observe this formula here is the same as the first formula which we found using the acute angle triangle, which is here. And that means that any of the triangle you use to find the formula of cosine rule, they are similar, and you can use them in whatever way you have found to solve whichever problem you encounter in your life. So we shall see one of the example. We shall see an example, but remember one thing, that these formulas which we have found here, which is this is the first formula, this is the second, and this is the third, depending on whatever you are looking for. They are only valid if you have been provided with the two sides and an angle included. And also, if you have been given all the sides but you have no angle, that formula works for only those conditions. We want to handle an example on cosine rule. And we have here, using cosine rule, find PQ, and this is my PQ, whereby you have been given this side at 4 cm, the other one is 6 cm, and this angle you have been given 78. degrees actually. So using cosine rule, we saw that if you want to find this angle, then it shall be r squared is equal to the other angles are then, that is, now it shall not be a squared but will be 4 squared plus 6 squared minus 2 multiply AB, or let me just first write that general formula, whereby we say c squared equals to a squared plus b squared minus 2ab cos c. Now, if we relate that general formula with our triangle here, we might call this side C, this side A, this side B, and then we give this angle C. So with that reference, now we shall say that C is R, now it will be R squared is equal to A, but our A is 4. So we are squaring 4 squared plus B, and our B squared will be 6 squared minus 2. We said A is 4, so it will be multiplied by 4, then multiplied by B, and B is 6, then cos of the angle C, and cos of that angle is 78. So we multiply by angle 78 degrees. And we are going to get, this one is going to give us 4 squared is 16, 16 plus, we are going to get 52 minus, now 4 by 6, 24 by 2, 48, so we are going to get 48 multiplied by cos 78 is going to give us 0.2079. Let's just use up to that 4 decimal places. So if we do that, we are going to get 48 multiplied by 0.2079. We are going to get is 9 point, now it will be 52 minus 9.9792, and this one is going to give you, if you subtract here, you're going to get 42.0208 square centimeter. That is what we are going to get as the value of r squared. But we need to find only the value of r. So what we do, we find the square root on both sides. And if we find the square root on both sides, we are finding that our r here, which we require here, is equal to square root of 42, square root of 42.0208, and you shall find that side is 6.48 and some more, so to 2 decimal places it will be 6.48 centimeters. And with that, we have seen, if you have been given 2 of the sides of a triangle and 1 angle, you can still use cosine rule to find that there are missing part or missing value. And then sometimes you may find you are being provided with the angles, and one of the sides, actually you may be provided with the sides without the angle. All the sides have been given but no angle is given. You can still use the same approach or the same cosine formula, and you will find the angle which is missing or which you are requiring. With that, we have come to the end of this chapter, Trigonometry 2.